Hello, welcome back and to the very last video of the year. Can you believe it? We've made it. Okay, this is our section on solving logarithmic equations now. Last section we did exponential functions. This time we're going to do logarithmic functions. We are going to learn how to apply, however, a little bit of modeling to this, which is going to include a little bit of exponential functions. Okay, so this diagram shows how a forest fire grows over time. So we have, 0 minutes, 4 acres it starts, and after 1 minute it's covered 7.2 acres, after 2 minutes 12.96 acres, and after 3 minutes 23.3 acres, and so forth. The fire department can contain a 160-acre fire without needing any additional resources. About how many minutes does it take for a fire to become too big for the fire department to contain without additional resources? Okay, so right here we have, first of all, our number of acres is 160. Okay, that's our kind of a result, I guess. And then our starting point right here is 4 acres. That's our initial number, 4. Our growth rate, how we come up with that is, we take each of these ratios right here. If we take, let me get my pen. If we take this right here, this 7.2 divided by 4, that gives me a 1.8. Okay, that's a ratio of 1.8. If we take this 12.96 divided by 7.2 also, we get also 1.8, that ratio. And also this ratio of 23.3 divided by 12.96 is also 1.8. So that is a growth rate of 1.8. So that's how we get that growth rate, okay? And so we end up with our equation right here that we're going to have is our y equals, or actually 160 equals our 4 and then times 1.8 to the t time, okay? And it's asking us how much time has it taken us to get to 160 acres, because then we're going to need additional resources. So this is just an exponential function like we did last time. So we're going to just, first of all, initially divide by 4 here, and we're going to end up with our 40 equals 1.8 to the t, okay? And then what I'm going to do here, then I'm going to take the log of both sides. So I take my log of 40 here is going to equal my log of 1.8 to the t. Okay, now I can take that t out in front. So I'll have my log of 40 equals my t times log of 1.8. And now I can isolate that t all by itself, right? So I can take and divide by my log of 1.8, divide by my log of 1.8. And I'm going to get my t is approximately equal to, let's go ahead and pull up my calculator. So I have log of 40 divided by my log of 1.8, and we should get about 6.276. So 6.276. And so what does that mean? That means it's going to take about 6 minutes, a little over 6 minutes, before the fire department is going to need additional resources to help them with the fire. It's not very long, okay? Next here, it's say now how many minutes does it take for the fire to spread over 100 acres? So this time we're going to say that our result here is going to be 100 acres. And of course, we're still going to start with 4. Our ratio is still 1.8 and over time, right? So we're still going to, we're just going to kind of find out when is that going to equal 100 acres. So we're still going to divide by 4. So we have our 25 equals 1.8 to the t. And we're going to just, again, take the logarithm of both sides. So a log of 25 equals log of 1.8 to the t. So my log of 25 equals, we'll use our exponent property there to pull that t out in front, log of 1.8. And then we'll divide both sides by log of 1.8. So it'll give me approximately my log of, actually that's equal still, log of 25 divided by log of 1.8. That should actually still be an equal sign because we haven't evaluated the log yet. So t equals, and then we'll calculate that again. So I have again log of 25 this time divided by my log of 1.8. And that's going to give me 5.476. So it's about 5.476. So it's going to take about, about 5.5 minutes for it to spread to 100 acres. Okay. So that's kind of how you set up those little story problems, okay? Okay, so now we're going to get into solving logarithmic equations, okay? So first of all, what's my original equation? We just have this natural log of x minus 16 equals natural log of 6. So natural log of x squared minus 16 equals my natural log of 6x. We're going to apply our property of equality. So if we have the logs of the same base, which these both are, they're both logs of base e, that means that x squared minus 16 is going to be equal to 6x. Okay, so now since we have a quadratic equation there, we're just going to get everything equal to 0. So we're going to subtract 6x from both sides here, and we'll end up with our x squared minus 6x minus 16 equals 0. And we'll just factor that guy. So factors of negative 16 add up to negative 6 is going to be 8 and 2. So it will be x minus 8 times x plus 2 equals 0. So my results are going to be x equals 8 and negative 2. Now we need to check these guys, okay, because we could end up with some extraneous solutions. So let's plug this back into our original function. So we're going to go natural log of 8 first of all. So 8 squared is 64 minus 16 equals my natural log of 6 times 8, which is 48. Okay, 64 minus 16 is 48. So equals a natural log of 48. And this is true. Okay, we don't need to actually calculate it. We know that this is already a true statement. We're good to go. Okay. The other one is going to be natural log of negative 2 squared. So that's going to be 4. So 4 minus 16 equals a natural log of 6 times negative 2 is negative 12. So we have natural log of negative 12 equals a natural log of negative 12. We really don't even have to go that far because we already know if we have a natural log of a negative number, not going to happen, right? So not going to happen. So our only solution is going to be x equals 8 in this case. Okay, so watch out for extraneous solutions. Okay, so you might want to try it. Go ahead and pause the video for a minute. Try this guy and see how you do, okay? All right, so we have, again, logs the same base, so that means that our arguments are the same. So x squared minus 45 is going to equal 4x. So we have a quadratic function. We're just going to subtract 4x from both sides. So x squared minus 4x minus 45 equals 0. So factors of negative 45 that add up to negative 4 will be our x minus 9 times x plus 5 equals 0. So I'll have x equals positive 9 and negative 5. Okay, so now let's check those guys. Let's check both of those, make sure we don't have any extraneous solutions. We have log base 5 of 9 squared is 81 minus 45 equals my log base 5 of 4 times 9 is 36. Okay, this is log base 5 of 81 minus 45 is 36. That's equal to log base 5 of 36. So this is okay. That one checks out good. Check the other one. Log base 5 of negative 5 squared is 25. So 25 minus 45. Whoops, minus 45. Got ahead of myself. Equals log base 5 of 4 times negative 5 gives me negative 20. Okay, so we have log base 5 of negative 20 equals log base 5 of negative 20. So remember, we cannot take the log of a negative number is undefined, right? So this cannot be true. So our only solution is x equals 9. Okay, and so that's solving our logarithmic functions. Now, what I want to do is kind of put this all together, both for exponentials and logarithmics. And what do I do for all these? So what's the difference between these two here? Well, this one here, I can just write an exponential form, right? Or excuse me, logarithmic form. I can go log base 5 of 32 equals x. I can use change of base formula here. Log of 32 over log of 5 equals x. Boom, I'm done. Okay, I can even just take the log of both sides. This guy here, I have to take the log of both sides because I don't have this, can't get the same bases. So I'm just going to take the log of both sides so I can bring the x's out in front. And I'm going to have to take a little bit more effort there to solve that guy. Okay, so I take log of both, log of 3 of x plus 1 equals log of 5 of x. I bring those x's out in front and I have to distribute that log and so forth. So you guys should kind of remember that from our last lesson, okay? This one here, we have two logarithms. So we have to put them together to one logarithm, okay? And before we can solve. So we'd have to take, this is going to be log base 2. And we'd have to multiply these two. X times x minus 3 equals 2. Okay, now I have a single logarithm. I can go 2 squared. 2 to the second power equals x times x minus 3. So now I have 4 equals x squared minus 3x. Okay, 0 equals x squared minus 3x minus 4. If I take that 4, subtract that 4 over. Now I can factor this. X minus 4, x plus 1, and I have x equals 4, negative 1. And of course, I'd want to check that again. And I'm not gonna do that right now. I just kind of want to show you the different methods of how we're going to solve each of these. Okay. So whenever we have 2 logarithms, we need to condense them into 1 logarithm before we can solve. Okay. What do we have to have here? So now we have an e with a variable in the exponents. We have to use a logarithm, and since it's a base e, we're going to use a natural log. But the first thing we have to do is isolate this guy all by itself. Okay. So we're going to add 3 to both sides, if you recall that. So we have 2 e to the 5t equals 253. Okay, then we'll divide by 2 because we want to get that whole e all by itself. Okay, e to the 5t equals, and then we're going to take our 253 divided by 2. And it gives me 126.5. And now I can take the natural log of both sides, right? Natural log here, natural log here. So I have 5t natural log of e equals my natural log of 126.5 is 4.84. Okay, this becomes 1. Natural log base e of e just becomes 1. So it's 5t equals 4.84. So I divide by 5. T is approximately equal to, so I take that 4.84, it's divided by 5. That gives me about 0.968. So about 0.968 for my value of t. Okay, so just kind of reminding, what we did in our past units and so forth. Okay, here notice I have the same log with the same base. Log equals log same base. This is kind of what we just did. So that means that our arguments are equal. Okay, so x squared minus 15x equals 2x, and I can solve from there. And I'm not going to continue there because we just kind of did a whole section on that just now. Okay. This is similar to the one we just did with the e. This time I just take a log. So I divide by 1040. I'll just go ahead and do this. So 0.96 to the t would equal 675 divided by 1040. 0.649. Okay. So now we just 0.96. I'd use a log. So I take a log of 0.96 of 0.649 equals t, and then I could change base right here, right? Log of 0.649 divided by, that's a 9, divided by log of 0.96 equals t, and I could calculate that out, okay? I could also up here just take the logarithms of both sides right here, okay, as well, and it'd end up in the same spot as you would down here, okay? So same thing right here. I would just want to subtract this 2. Get this logarithm all by itself. So we have the opposite of log. W minus 17 equals negative 2. Then I want to get rid of this negative. Okay, so I take my log W minus 17 equals a positive 2. Now I can write this in exponential form. So 2 to the second, or 10, excuse me, base 10 to the second power equals W minus 17. That gives me 100 equals W minus 17, which gives me 117 equals W, okay? And so just kind of going through all the things we kind of been through this section, all the different ways we can solve for logarithms or exponential functions and so forth. This kind of gives a summary of the whole section we've talked about on property of equality for exponential functions, property of equality for logarithmic functions, and just kind of how to go about from each one. When you have variables in your exponent, how to solve it, and we have logarithms in your equation, how to solve those. Okay, so you have an Excel in Google Classroom. It's been awesome making these videos every week. Congratulations to our seniors out there, and you survived the coronavirus year, and I'm so happy you get to have a live graduation. I will see you guys soon, and take care. All right, bye-bye.